Hello, and welcome to 5 Minute Math. My name is Aaron Daffer, the creator of the 5 Minute Math series. We are looking through the entire third grade 2023 STAAR test. I'm using a custom item analysis report from the state of Texas. You can grab it using either the link in the description or the QR code on the screen. If you want, you can jump ahead to any item, either using the timestamps you see on the screen or by using the bookmarks embedded in the video. For number 1, we are comparing fractions. This is TEKS 3.3H, a rated standard in reporting category 1. So we simply need to find the true comparison here. And one thing we should be able to eliminate immediately is going to be B, 2/3 does not equal 2/4. You can have two fractions that are equivalent, but you can't have the same numerator and two different denominators. 2 out of 3 equal parts is not going to be the same as 2 out of 4 equal parts. So how do we compare the rest of these? Well, take a look. All of these numerators are even. Actually, all 4 answer selections have numerators of 2. So what do we know about that? Well, what I'm going to do is I'm going to draw some shapes here to kind of demonstrate what we want our students to be able to do, right? So if we were to draw these two shapes, right, those are two equal parts. And so what we would want is we would want them to say, okay, so if I've got 4 equal parts and I've got 6 equal parts, well, you notice that the 6 equal parts are going to be smaller because I took that exact same shape and I cut it into 6 parts. And each of those parts, by definition, are going to be smaller than that same shape that I cut into 4 equal parts. So the bigger the denominator, the smaller each part is. So 2/4 is going to be larger than 2/6. That makes sense. You notice that C is the exact opposite. They just flip the 2/6. 2/6 is not greater than 2/4. Now we can look at the same thing for thirds and eighths if we want to. Right, so let's draw that same thing just so we can compare apples and apples. And on the STAAR test, they can use this connect line feature if they want to do this, but they can actually compare without that. So here's my thirds. Let's see if I can make my eighths. Look how tiny each of those eighths are. So I've got my 2/3. Only cutting that into 3 equal parts means each part is going to be very large. And they say 2/3 is less than 2/8, but actually it's much larger. Right, so our answer here is A. Let's see how we did across the state of Texas. So this was the fourth easiest problem, and we see that most of our students avoided this obviously incorrect answer, so that's good. But we do see here two different options in which students are probably mistakenly seeing the larger denominator has to be the larger fraction, and that's one of those core ideas of fractions that we need them to understand. The larger the denominator, the smaller each piece is going to be. So without drawing pictures, they could have answered this because as long as the numerators are the same, you could just evaluate the size of the denominator. Obviously, the pictures are going to help for some students that still need that visual backup, but as long as the numerators are the same, we can compare by just saying, well, the larger the denominator, the smaller the pieces, which means the lower the denominator, the larger the pieces, and that's what we wanted. For number 2, we are looking at equal shares. This is TEKS 3.4H in reporting category 2. So Lupita has 26 pieces of candy. She puts 2 pieces of candy into each bag. And so hopefully we see a few different things here. Hopefully we see that we are looking at has 26 pieces of candy, so that's my total. 2 pieces of candy into each bag. Okay, so that's going to be equal groups. And so we're dealing with equal groups. That means we are going to either multiply or we are going to divide. So what are we doing here? Well, we have our total. It's not like we're getting more candy. We have 26 pieces of candy. We're going to put them in sets of 2. My question is, how many sets of 2 can I get? Well, I could divide 26 divided by 2. Might not necessarily know that fact, might not know how to do long division. So in this case, let's just use the picture. I'm just going to put groups of 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I'm thinking there's 13 bags. Let's double check. 13 times 2 makes 26. There we go. 13 is my answer. D, let's see how we did across the state of Texas. So this was the second easiest. You see, we had over 3/4 of our students get it correct. How do we get some of these incorrect answers? Well, 2 might be if they simply just found that number 2 and thought that was the answer. 24 is if we are going to take our 26 and our 2, but instead of dividing, we are going to subtract. That gets you 24. And then this 3, that's a little bit random. Maybe they saw 3 rows, even though this one is incomplete. But either way, most of our students did a really good job of using this picture to divide 26 by 2 to get 13. For number 3, we are looking at the composite area of a rectangle. This is TEKS 3.6D in reporting category 3. We need to find the area of the shaded figure, and they give us the grid lines. Now, we could do it without the grid lines if we wanted to, and what we want students to see is that even though this isn't necessarily a rectangle, what we could do is we can find the area of the two smaller rectangles that are adjacent to each other that are non-overlapping, right? This is the additive property of area. So we can say, all right, so we've got a 2 by 3, so this is 1, 2, 3, 4, 5, 6, so that's an area of 6. And then this is a rectangle of 1, 2, 3, 4, 5. This is a 2 by 5. So that is going to be area of 10. Add those up, and you get 16. Or you could do it this way. You can say this is a 3 by 4. So this is going to be an area of 12 if you want to do it this way. And so we'll put our 12 there. And then this is a 2 by 2. And that's a 12 plus 4. Either way, it equals 16. Or you could just keep it as one big shape and count how many gray squares there are. This is a pretty straightforward problem. Our answer here is D. Let's see how we did across the state of Texas. So this was the third easiest. We had exactly 75% get it right. But take a look at this. We had 12% of our students get 20 square feet. Now, how do you get more than the 16? Well, some of our students might be unfamiliar with this composite area. They might be used to everything being a rectangle. So if you were to shade these 4 in, well, guess what you've got? You've got a 5 by 4. There's your 20. So we need to provide our students opportunities to have these composite shapes to let them know that you can have an area of something that's not a rectangle. You can break it down into smaller rectangles if you want to, but that we only are going to be counting the shaded portions, and we don't fill it in to make a bigger rectangle. For number 4, we are representing multiplication and division. This is TEKS 3.5B, a readiness standard in reporting category 2. So we had a total of 32 magnets attached to 8 metal cabinets, an equal number. So these are some key words that we should be latching onto. When they give us a total, right, that lets us know that's going to be the largest number that we see there. Okay, so a total of 32 magnets. So I'm going to draw a strip diagram here. You see all of our answers are strip diagrams. So my total is going to stretch across the strip diagram. And you notice that I've got this right here and this right here. They don't include 32 as the total. They include 32 as the part. But number 4 says 32 is the total. So I'm going to get rid of these two. Attached to 8 metal cabinets, an equal number of magnets were attached to each cabinet. So the 8 cabinets are the 8 groups, and I've got equal groups. So it looks like I'm going to have my 8. So I'm going to draw a big long bar, cut it in half, cut the half in half to make 4s, and then cut each fourth in half to make 8s. So that's what I'm looking for. I need to split my 32 equally into 8 groups. And you see what I'm doing is right there. Now, we know that we can take 32, we can divide it by 8, right? Equal groups means we're going to either multiply or divide. In this case, we're dividing because we have our total, right? It's going to be 4. So this makes sense if I put 4 in each of these. You notice that D here is a part whole. That's a subtraction, right? So this is more of 32 minus 8. The problem is that doesn't equal 4, right? That's going to equal 24. And you can't have 24 attached to each cabinet because there's 8 different cabinets. We're going to get way larger than what we need to. So our answer here is B, Let's see how we did across the state of Texas. So this was the 12th most difficult here, and you notice that we're a little bit spread out. We only had 40% of our students get the correct answer, and so hopefully we notice here that we've got this is going to be 8 times 32, right? This is 8 plus 32. This is 32 minus 8, right? And this is your 32 divided by 8. So all of these representations use the number 8 and use the number 32. So we need to make sure our students have enough practice with reading these problems, looking for a total. When you see a total, we know that that's going to be uh, going across the entire strip diagram. And when we see an equal number, that equal groups is going to be our clue that we are going to either be multiplying or dividing. For number 5, we are looking at the concept of saving money. This is personal financial literacy, TEKS 3.9E, reporting category 4. So this is a multiple select. We need to find 2 correct answers, but automatically we are going to have some vocabulary issues, right? So hopefully we know what saving is, but we need to know what benefits are. Because if we don't know that benefits are the positive effects, right? It's good things, then we are going to struggle. So what are the positive effects or the good outcomes of saving money? Well, we have to know that increase means to grow, right? And then debt, we have to know what debt is. Debt is when you owe money. So when you save money, you don't increase the amount of money you owe, and that's not a good thing anyways. To increase interest, okay, so we need to know what interest means, right? So that's money paid on borrowed money or on loans. And do we want to increase that? No, we don't want to increase the money paid on borrowed money, and you don't really have interest on monthly bills anyways. But you see how this is very much a vocabulary problem and just a background knowledge problem, not necessarily a math problem. To prepare to pay for college, yes, saving money for college definitely works. To help spend money faster, and I guess you could spend money faster if you save money, but I don't know if that's a benefit of it. Let's see if that last one is a little bit better. To help pay for unplanned needs. All right, so that's a big idea. Yes, saving money helps you pay for unplanned needs, so that's a better answer. So my answer here is going to be option 3, option 5. Let's see how we did across the state of Texas. So this was the 10th most difficult. We only had 38% of our students get both points. And then we had 47% of our students get 1 point. So if you put those together, that's not bad. That's 85% at least getting 1 point. But we don't know from our statewide item analysis which items were selected at what percentages. They don't give us that level of detail. How do we teach personal financial literacy? Well, I would step over into the realm of RLA and I would have the students read some articles. I'm sure we can find some argumentative articles and some informational articles, have them write about it. Either give them a prompt for an extended constructive response or short constructive response, what they have to do on the RLA star. Have them write about the benefits of saving money because as they are able to pull evidence and justify their opinion or take a stand, that's going to help them know more about personal financial literacy, and that's how they build that background knowledge. For number 6, we are determining volume and weight. This is TEKS 3.7E and reporting category 3. This is actually the first time that this standard has ever been tested on a STAAR test. So let's take a look at it. Hannah gets a juice box like the one that she sees, so obviously we immediately have to be able to just pick out the juice box uh, out of her entire tray of food. And then we need to find the measurement that is closest to the amount of a full juice box. So we have to understand, all right, let's fill that up. And then we get milliliters and liters. Okay, so hopefully our students have a frame of reference on a 2 liter because that's something that they constantly will see at the store. And I'm going to try to draw one here, but let's say we get a 2 liter of Coke, or Pepsi, or Mountain Dew. It's big. Hopefully they know that this is a 2 liter and that it's, if you don't drink it very fast, it gets flat. So we want students to have this as a frame of reference. Okay, so that is going to be way larger than a juice box. Obviously, 200 is going to be 100 times larger, so that's too big. So we're stuck with milliliters. So we need to have a 2-liter in mind as a reference for our liters. But we need to have an eyedropper in mind. So an eyedropper is probably going to be a good representation of a milliliter, right? There's 1,000 milliliters in 1 liter. So there's 1,000 little drops, eyedroppers, in that bottle of a liter. And so that's going to be too small. So we're stuck here with 200 milliliters as the best option. And so our answer here is B. Let's see how we did across the state of Texas. So this was tied for the fourth most difficult. And you see that the correct answer was the third most chosen, right? We had more students choosing 2 liters or 2 milliliters. And so maybe it was this number 200 seemed a lot, uh, way too much, right? And this actual unit 2 was going to be better, but obviously it makes a difference what the unit is right behind it. The 2 milliliters and 2 liters are totally different. So we don't have a good frame of reference, it seems, for these units, milliliters and liters. I would highly suggest when you teach 3.7D, 3.7D simply asks students to determine when it's appropriate to use measurements of liquid volume or measurements of weight. So would you use capacity? Would you use, pounds or ounces to measure this? But go ahead and put that together with 3.7E. So once you determine whether you want to use like units of measurement of capacity or units of weight to measure something, estimate it. Estimate everything so they get a good frame of reference of what a full juice box would be. For number 7, we are representing addition and subtraction problems. This is a readiness standard. TEKS 3.5A in reporting category 2. So we had a cafeteria, had 280 ice cream bars. So hopefully we're saying this is our total, right? And during lunch, some of the ice cream bars were sold. And after lunch, there were 130 bars left over. So I'm thinking here, right, we can just draw a strip diagram. I've got 280, that's my total. And it's looking like a part whole, right? Some ice cream bars were sold, right? So that means we're going to subtract. So I could do that if I have a question mark here, and then 130 bars were left over, right? So 280, right? I could subtract the question mark. I don't know what that is, but I could subtract the other part and I can get how much was sold. All right, so I'm looking for this. 150 were sold. Now that I know that 150 were sold, because my 150 plus 130 is going to make my 280, I need to find a representation. But as you can see, I drew a strip diagram, but that doesn't work here. Because I know that there's 150. Always recommend finding the actual answer rather than just looking for the representation. That doesn't make any sense. That 280 needs to be the total, not one of the parts, right? And that's basically kind of what we're doing on A here. Look at that, 150 minus 280. It would end up being negative, right? It'd be a negative 130. We don't get into negative, so that's not going to work. This would be an addition. Once again, it's making the 130 the whole, and I need the 280 to be the whole, and that doesn't make any sense. So we're stuck with D. So what are we doing here with D? Well, I've got a number line here, and I'm counting by 20s, so 240, 260. So there's my 280. So I've got a 280 right there, and what do I have right here? I've got a 120, 130. Okay, so what they did is they added 280, and then they went backwards, and they got to my 130. Okay, so there's my 130. And how much did they take away? Well, let's see. I've got 20, 40, 60, 80, 100, 120, 140. Add a 10. There's my 150. So they used a number line to represent that. So that's my answer, D. Let's see how we did across the state of Texas. So this was the 8th most difficult problem. Take a look. We knew that we were selling some stuff, and we knew that subtraction here. So some people probably saw this, 130 left over. Okay, so that makes me think that might be the total, but that doesn't quite make sense if we were to put it into a strip diagram. So students that chose this, which is the most popular answer, probably were just looking for a few keywords, but they didn't make sense of the entire problem. And then here, maybe they represented this as a part whole, but then that doesn't make sense. If you're going to add those together, that's 410, right? In both of these situations, that's going to be 410, but where's 410? It says you only had 280. So what we see here is that third grade is much more about adding, subtracting, multiplying, dividing. It's about representations. And can you represent addition, subtraction, multiplication, and division? Because if you can't represent it, you are going to struggle in third grade. So I would suggest whenever we get a problem like this, have students do multiple things. Have them actually solve it, but then have them represented with an equation, have them represent it with a strip diagram, have them represent it with a number line, because if they could do it 3 ways consistently, that's going to help build their schema for representing addition and subtraction problems. For number 8, we are classifying shapes and solids. This is TEKS 3.6a, a write-in standard, in reporting category 3. So we have a group of figures. We need to find the statement that is true about all figures. Lots of vocabulary here. So what do we know about these terms? Well, we need to know what a parallelogram is, right? So if we were looking at a Venn diagram, a parallelogram is going to be a shape that is, first off, it's going to be four-sided, right? And it's going to have two sets of parallel lines. So it can be a rectangle, it can be a square, it can literally just be called a parallelogram. You also have a rhombus. So all of those are parallelograms. So this one works, none of the other ones do. So it's not that. All figures are polygons. Well, what in the world is a polygon? Well, a polygon is much bigger than a parallelogram. A polygon is a shape that is both closed and has straight sides. So inside the polygon would be parallelograms, right? And parallelograms actually exist in a little bit larger circle, quadrilateral. So we have four-sided shapes, a lot of which are parallelograms, but not all. You can have trapezoids out here that are not parallelograms. But then you've got triangles, three-sided shapes that are closed, straight sides, right? Then you've got hexagons, six-sided shapes, right? You've got octagons, you've got all of these different shapes that don't necessarily overlap, but they're all a polygon. So do we have closed shape with straight sides? Yes, 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 and yes. So that's looking good. All figures have equal side lengths. Well, definitely no on this one. This is a hexagon. It is a regular hexagon, so I do see that it has 6 equal sides. This is definitely not equal length, but this triangle is. It looks like an equilateral triangle. So only 2 out of the 4 prisms, yeah, that's not going to work. Prisms are three-dimensional shapes, right? Like cubes, rectangular prisms, triangular prisms. That's what we're dealing with. None of those work. So our answer here is B. See how we did across the state of Texas. So this was the 12th easiest, right? We had just a little bit over half our students get it correct. The most chosen incorrect answer is parallelogram. And what this makes me think is we are unsure of the definition of this. Think about all the definitions we need to know. We need to know what a parallelogram is. We need to know what a polygon is. We need to know what a prism is. Now this, you could probably figure out without necessarily know the definition, but this is a standard that deals with vocabulary, not so much adding, subtracting, multiplying, or dividing, any type of calculation. So we need to help steep our students in classification based on attributes of two-dimensional, three-dimensional shapes, which means for number 9, we are solving addition and subtraction problems. This is TEKS 3.4a, a readiness standard in reporting category 2. So we have Miss Green with some fabric, and she makes 69 yards for play X, 48 yards for play Y, 53 yards for play Z. Now here's where it gets tricky. She also has 27 yards left over. So how many yards of fabric did she start with? Okay, so that means I'm looking for the total. That's missing. So if I want to make a strip diagram, what do I know that she used? Well, I know that she used 69 yards for play X. I know that she used 48 yards for play Y. I know that she used 53 yards for play Z. But then she had 27 yards left over, which means that's the part. So that's a strip diagram that I could use. Or I can say leftover 27 yards. You need to add that 27 into there. Okay? So let's use the way that they lined it up for us, right? That's 10 and that's 17. So 10 and 17 make 27. That's another 10. And that's going to be 12, 17, 19, 197 yards to begin with. So my answer here is B. Let's see how we did across the state of Texas. If you were thinking this would be tricky, you were correct. This was the seventh most difficult. Take a look. 51% of our students chose 170. How do you get 170? You just simply add these three. I mean, it's right in front of you, right? Well, what do we do in third grade? We add columns of numbers. So you take these three numbers, you add them up, you get 170, and you're done. But that doesn't take into account this 27. So this was very difficult because the visual, if we're not a good reader or if we're kind of skimming, makes us think we just need to add these up. And if I do that, I find the answer, I'm moving on. Now, we did have some students that took the 170 and then they subtracted the 27. They at least tried to do something. That's what this is going to be here. And this is if you add it all together, you just don't regroup the 27. So this is a very difficult problem. I would highly suggest taking it out of the table, using a strip diagram to visualize it, because once they see that, they see the relationship, they think, oh, it's part whole. I got to do something with that 27. For number 10, we are looking at even and odd. This is TEKS 3.4i, reporting category 1. So we just need to figure out what we know about this number 510. Now, this is where it gets a little bit tricky. Hopefully our students know, right, that if a number is even, that means its ones digit is going to be 0, 2, 4, 6, or 8. If it's going to be odd, it's going to be 1, 3, 5, 7, and 9. This is the ones digit. So if we know this, right, we can at least get rid of A and B. But why is it even? Right? If they just know it's even because the ones digit is 0, 2, 4, 6, or 8, that's not one of the answer choices. So there's two answer choices that include the word even, but we need to know why. So what makes this even? Is it because it could be divided by 2 evenly? Or is it because the tens place is even? Well, first off, we don't look at the tens place, we look at the ones place. Secondly, it's not even. The tens place is a 1, and that's odd. So this is wrong both different ways. Even though we teach them the shortcut, guys, just look at the ones place. If it's 0, 2, 4, 6, or 8, it's even. What that means is you can split it evenly. So if I have my number 10, I know it's even because the ones digit is a 0, but that also means that I can split it evenly into two groups. And if I have a number 7, I know it's odd because it's got its ones digit of 7, but I also know it's odd because I cannot split it evenly into two groups. So they need to understand that an even number can be cut evenly or divided evenly into two equal groups. So our answer here is C. Let's see how we did across the state of Texas. So this was the 14th easiest, kind of right in the middle of the pack of a 30-question test. You see, we just had half of our students get it correct. But you notice not many students chose this because they knew the tens place was not even. Okay, so we knew that was wrong. But take a look at our most incorrect answer. It is odd because the digit in the hundreds place is odd. Well, that's correct. The digit in the hundreds place, 5, is odd. But they don't know that has nothing to do with whether the number is even or odd. So we need to help our students practice, first off, understanding the shortcut, right? The 0, 2, 4, 6, or 8, that makes even, that's great. But we also need them to understand why, because you could take any even number and divide it into two even groups. And you can take any odd number, and it is impossible to divide them into two even groups. That's what makes a number even or odd. For number 11, we are representing data. This is Readiness Standard 3.8a in reporting category 4. So we have a dot plot here, and we simply need to find the list of numbers that this dot plot represents. All right, so the easiest way to look at this is think of it like a number line and a bar graph are mixed together. You see I've got one dot above the 1, so I can list 1, 1. One dot above the 2, I can list 1, 2. There's nothing for the 3, so I'm not going to list a 3. So that's going to be incorrect right there for B. That just lists all 10 numbers. I've got 2 dots above the 4, which means I need 2 4s. So we notice that D is the only one there that's got 2 4s. I've got 2 dots above the 5, which means I need 2 5s. D is the only one that's got the 2 5s. There's no 6s, but I do have 2 7s. So once again, D has got the 2 7s, 1 8, and 1 9. So my answer here is D. Let's see how we did across the state of Texas. So this was actually a little bit more difficult than we might have thought. 14th most difficult. You see, less than half of our students got the correct answer. Now, what they did choose tells us something about what their concerns are or what their challenges are with this particular problem. Look at this, 38% simply chose each of the numbers that were represented, right? So I've got a 1, a 2, no 3, a 4 and a 5, no 6, 7, 8, 9, and then no 10. So rather than looking at how many dots were above each one, they simply looked at which numbers were represented. Then, of course, 15% of them still just chose all 10 numbers on the bottom, regardless of whether or not they had a dot above them. So this means we have a lot of opportunity to turn frequency tables, right? Let's just turn frequency tables. Let's just do 1, 2, 3, 4, 5. Let's just do this, right? So we should hopefully see 1, 1, 2, 2, 2, 2, and then we continue on with 6, 7, 8, 9, 10. Give students a frequency table, have them create their own dot plot, have them draw everything, not a halfway filled out worksheet. Because once they draw it themselves a few different times, they will know, okay, so each time I have a tally mark here on this frequency table, that's going to represent a dot. So 2 tally marks means 2 dots. All they need to do is get that a few times, and they can do problems like this a lot simpler. For number 12, we are looking at real-world number pairs. This is a readiness standard, TEKS 3.5e in reporting category 2. So we've got inline choice here. We've got 2 blanks that we need to fill out here. So let's take a look here. We've got Isabel selling clothing online, and so it actually tells you what we need to do in this problem right here. It says she sends a free gift, so that's a +1. One free gift to each order. And take a look what's going on here. So someone orders 5, she gets a free gift, sends it to them, so they get a total of 6. Someone orders 3, she sends a free gift, they get a total of 4. Same thing with 6, free gift, total of 7. Right? So how can we represent that in word form here? So the number of items ordered, well, we are adding the number 1, and that equals the number of items sent, which does work for what we have here, right? So the number of items ordered, 5, plus the number 1 equals the number of items sent, 6, or 3 plus 1 equals 4, 6 plus 1 equals 7. All right, so that's how we get full credit for this 2-point problem. Let's see how we did across the state of Texas. So this actually ended up on the easier side. This was the 13th easiest. You notice that we had 51% of our students get full credit. Now, it's kind of hard to get one of these right and one of these wrong. You saw we had 25% partial credit, but with the exact same amount for no credit, my thought is that we just had some students guessing, and if they didn't know what they were doing, they just picked some numbers, and some of them got one of them right on accident. So it really looks like half of our students knew what they were doing, and half of our students were kind of clueless. I don't think students probably had difficulty figuring out the pattern here, +1. The challenge for this one is that the answer is not simply +1. They have to put it into a complete sentence with just words and then just one digit right there. So this means that we have to give students opportunities to look at these real world number pairs and then verbally describe them to each other. Write their own sentence, right? across this whole part art and have them write a sentence using words describing the relationship. Because if they can do that, then they can solve this problem. For number 13, we are comparing and ordering numbers. This is a readiness standard, TEKS 3.2D, and reporting category 1. So we've got 4 different lists of numbers. We need to find the one that contains numbers, and then you see that we've got 2 boundary numbers here, right? So 5,000, 5,090, and then 6,300. So what I'm going to do is I'm going to just draw a number line here. Let's just draw a number line, and let's say that's 5,000, and let's say that is 6,000. So I'll kind of do my midpoints here at 5,500, and then I needed to add a 6,500. All right, so that'll be close enough. So in blue, I'm going to write these two numbers. So 5,090 right about there. And then 6,300 is going to be right around there. All right, so let's take a look at our options. So first off, let's just take A off the table. Look at these. I've got 5,000, 6,000. This is 53. Okay, so this is by a magnitude of 10, way beyond what we're doing. So A is just easily wrong. Now, take a look at B right here. I've got 5,009. So if I need to compare 5,009 and 5,090, you see that 5,009 is going to be smaller because it has 0 tens, which means it goes right there, which means it's outside of my boundaries. I need it to be in between these blue numbers. So I can automatically get rid of B as well. So A is out and B is out. Let's see what I got for C. 5,450. All right, so that's going to be right around there. 5,450. 6,215 right in front of it. Okay, so we're good so far. 6,381. Look, it's outside because that it's 81 more than 6,300. So it's not that. So it needs to be D. 5,746. So that's right smack in the middle there. 6,099. Or maybe right there, 6,099. And then 6,211, still in front of my 6,300. Yep, so all three of those work. My answer is D. Let's see how we did across the state of Texas. So this was the 13th most difficult. You see that we couldn't even get 50% of our students getting it correct, only 42%. Students most likely needed to draw some type of number line. They needed a visual because just trying to eyeball these two numbers and trying to find whether greater than or less than is going to be very difficult. So I'd highly suggest students drawing some type of number line, even if they want to make it vertical, more like a thermometer, that would work. But we need some type of visual. We see that 33% of our students, right, at least they chose B, and even though that one doesn't work, right, these two do work, so it was 2 out of 3 correct. But the 10% that chose A, right, I mean, it goes to the wrong place value. That goes to the 10,000s. These go to the thousands. So we probably needed to help students create these open number lines, right? So I didn't start with 5,090. I chose the nearest thousand, that was 5,000, but I didn't make this go to 6,000 because I knew I'd have to go above 6,000. So that's why I did the 6,000 here, and I tried to estimate the distance to 6,500, right? So that's what we need to help students do is get practice of doing problems just like this, building their own open number lines, because once they get some practice with this, it'll make a little bit more sense. For number 14, we are looking at the area of a rectangle. This is TEKS 3.6C, a readiness standard, in reporting category 3. So we need to find 2 correct answers here. This is multiple select. There's 5 possible choices. So each square has an area of 1 square inch. Some squares have already been placed, so this lets us know how many squares are across for the length and the width. We need to find 2 rectangles that have an area of 24 square inches. So what we can imagine here is that we are completing each of these. So if we could draw this nice and straight, right, we can complete each of these and say, all right, there's all these extra squares here. And then what we can do is we can number them, right? So 1, 2, 3, 4, 5, 6, 7, 8. But rather than listing all the next ones, I'm just going to count by eights, right? 8, 16, 24. So this one's going to be good. I want one that's got 24. And hopefully what students see at this point is that I can multiply the length times the width to get my area, right? Because that's what we're going to end up seeing as an area formula is area equals length times the width. So there's my 24. So let's check what's my length. 1, 2, 3, 4, 5, 6. What's my width? 1, 2, 3, 4, 5, 6. Notice you have to count this one twice. Once across and once down. So that could be kind of tricky. If not, right, we can just kind of still fill this in. This might be a good visual for kids. Right, and they're seeing, all right, so I got 6, 12, 18, 24, 30, 36. So that's not going to be it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 times 1, 2, 3 down. That's not going to be it. That's 36. It's 27. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 7 times 5 makes 35, so that's not going to work. So let's hope it's this one. 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4. Yeah, 6 times 4 makes 24, so it's going to be my first and my fifth option. Let's see how we did across the state of Texas. So this was the ninth easiest, and if you put those that got 2 points and those that got 1 point together, right now you're looking at 83% of our students got at least one of these two correct, so that's not bad. If I were to guess, I would think that most of the students were able to get this one, and then they might have struggled with some of these others. Hopefully, they see this pattern here that you can just complete these right, and you can just count the number of rows and multiply that by the number of columns. That's a really efficient way to do this rather than numbering each and every one of these. For number 15, we are looking at multi-step multiplication and division problems. This is TEKS 3.4K, a readiness standard in reporting category 2. So we've got Martin here. Martin has 11 cages in his bird store. Each cage can hold 11 or 7 birds. The store has 21 birds in its cages. So let's do this. Let's draw some cages. How many cages do I have? I've got 11 cages. So I'm just going to draw 2 rows of 4. That gets me 8. And then I've got 1 row of 3. There's my 11 cages, right? So let's draw a picture. I've got 7 birds that could possibly go in each cage. Okay, so I'm going to write 7, 7, 7, 7, 7, 7, 7, 7, 7, 7, 7. So hopefully we see, all right, I've got 11 groups of 7. I've got a max of 77 birds. Now, the store already has 21 birds in its cages. Okay, so look, I've got 7, 14, 21. So these three right here already make 21. They're already taken. So what is the greatest number of birds that Martin can add to his cages? Well, how much is left, right? So 7, 14, 21, 28, 35, 42, 49, 56. So this is what I did. I said, you know what? There are 77 possible birds that I can put in there because I've got 11 cages. Multiply that by 7. 3 out of those 7 are already used. So if we subtract those, right, you can either do it two ways. You can say, well, 11 minus 3 is going to be 8 groups of 7, or 21 take away from 77 is going to be 56. But either way, our answer here is B, 56. Let's see how we did across the state of Texas. So this one was tied for the fourth most difficult. Look at this. 28% of our students got it correct. Look how close each of those are to 25%. When we see numbers that close to 25%, we think, all right, students really had no idea how to do this problem. They were most likely guessing. Now, you can get all of these correctly if you were to do, you know, the right math, right? So for A, what they did is they multiplied 11 times 7, right? And then added the 21. What they did for C is they took the 11, subtracted 7, and then took that away from 21. It's kind of random. And then lastly, you just add all the numbers 21, 11, 7, you get your 39. So there's a way to get each of these. This probably lets us know that students had, it's not hard math, it's hard understanding the word problem. And they had probably had difficulty translating each of this into, right, each cage equal group, right? So that means we're going to do 11 times 7, so we know that's 77. But then the store has 21 birds in its cages, so what do I do with that 21, right? Do I add it, or do I, what I did here is I subtracted it. And so I would highly suggest working on problems like this and draw pictures. They don't have to draw cages, they can draw squares. You notice how I didn't try to solve this by just looking at the words and picking operations. Draw a picture, because once you get your 77 total, taking away 21 hopefully would make people say, oh, look, that's 3 full cages, right? They at least they helped us out there by giving us 3 full cages. And then I can just count the number of cages left. But this works best when drawing a picture. For number 16, we are classifying shapes and solids. This is TEKS 3.6a, a readiness standard in reporting category 3. You notice we have an equation editor here, so we just need to type in our answer. So we have 11 shapes shown, and we need to find how many of them are polygons with more than 3 sides. So, polygon, we need to know those are sides, shapes that have straight sides, and also shapes that are closed. So let's cross off the ones that we know are not going to work. This is not going to work because it is closed, but it is not straight. Now, this is not going to work. It is closed and straight. It is a polygon. It's a triangle, actually, but it needs to have more than 3. So greater than 3. So 3 exactly is not going to work. So this one is going to work. That is a trapezoid. That is a polygon with 4 sides. That's also going to work. That's a polygon with 6 sides. Now this is closed, but it is not straight, so that's not going to work. Looks like we've got a rhombus or a parallelogram here that works. This is a strange looking, let's see, 1, 2, 3, 4, 5, 6, 7, 8 octagon. That works. Closed straight sides. Triangle does not work. And then we've got a strange looking pentagon here, parallelogram here, and rectangle here. So they all work. So how many did I have that actually meet the criteria? I've got 1, 2, 3, 4, 5, 6, 7. All right, so that's what we do. We just type in the number 7 down here. Let's see how we did across the state of Texas. So this was the second hardest problem on the entire test. And I believe this was more of the problem than this. I would hope our students would, even if they kind of struggle with polygons, they're like, okay, that's kind of weird, that's kind of weird. The issue is these triangles. I bet some of our students probably included those and changed that to a 9 because they weren't really paying attention. So we need to have students practice situations like this and include polygons that still need to be excluded because they don't have enough sides. So that practice problems just like this can be really quick. It can help them discriminate and succeed. For number 17, we are solving addition and subtraction problems. This is a readiness standard, TEKS 3.4a in reporting category 2. So we just have to figure out how many more t-shirts were sold than sweatshirts. So there were 107 t-shirts, 88 sweatshirts. So what we're doing here is we're comparing. So if we wanted to draw a strip diagram, we can kind of do it like this. 187 t-shirts, we get 88 sweatshirts. So we're not really having a total, we're simply comparing, and then the question is how much greater is this? What's this gap right here? Well, we can view this as a part whole if that helps us figure out that to compare, right, how many more? It lets us know that we need to subtract. So we just need to do it like this, 107 minus 88. Now we are having to subtract across zeros. So if that is a little bit confusing, right, we can just go ahead and do it with, place value blocks. So I've got 100, and I've got 7 right here. Now, problem is I need to take away 8 ones. I can't take away 8 ones. I only have 7 ones, so I need to break up this 100 flat and turn it into, and I'll just do 2 rows of 5, 10 tens. So that's what we do here. Now I can take one of my 10s, leaving 9, and I'm going to add 10 ones. So now I've got 17 ones. So now it's a little bit easier for me to subtract 8 ones and 8 tens. So I'm going to get rid of 8 ones, right? So there's my original 7, 8. So that leaves me with 9. Then I need to leave just 1 10 after I take away 8. So there's that 1 left over right there. So my answer here is 19. Let's see how we did across the state of Texas. So this was the 7th easiest. You see we had 60% of our students get it right. I kind of understand this 29 here, right? So if you want to subtract and you you borrow, but you don't really regroup there, right? So you just kind of be like, okay, that's 29 because that's a 17. You don't really change that 10 into a 9. That's a mistake, but it's understandable. But look at this 15%, right? And then we've got this 8%. Both of those come from adding, right? We had 107 and 88. So if you add it correctly, right, you get 195. And if you don't add that and regroup correctly, you get your 185, these two answers right here. So we had 23%, almost 1 out of every 4 students not recognize this as a subtraction problem. How many more is always asking us to compare, which means we need to subtract. And then we also needed a strip diagram to represent this. So this would be one point of emphasis for students. How are you visually representing this to make sure you understand the correct operation before you just jump in and start doing stuff with numbers? For number 18, we are explaining equivalent fractions. This is TX 3.3G in reporting category 1. So we have inline choice here. So what we need to do here is we need to select from these different choices. We got 3 different answers we need to fill in here. So first, we need to do is we need to look at point U, and look what it's going to ask us first. Point U can represent, I see, either 3/6 or 2 halves, or 3/4, 1 half, and 1/6. So let's see if we can get that down here. So 3/6 or 2 halves. So 3/6 or 2 halves. And then the second one is going to be 3/4. And this, I'm having to do this because you can't access these drop downs when you have the graph paper on full screen. So that's kind of a limit of the test. Okay, so those are my 2 choices. So what is point U? Well, I could just initially name it, and I could see how many parts there are, right? So there's 1, 2, 3, 4, 5, 6. So this is broken up into sixths, okay? And then the tick marks are going to represent the numerator, right? 6 is my denominator. I've got 1, 2, it's on the third one. Okay, so this is going to be 3/6. Represent 3/6, or these are my 3 choices. Well, I know it can't be 2/6 because 2/6 is going to be right there. So it's either going to be 1 half or 3/4. Well, that's not broken up into halves or fourths, okay? So what I need to do here is I need to try to reimagine this as either halves or fourths. Let's start with my fourths. If I were to do anything in fourths, what I do is I cut it in half. And you see how that looks like that's sitting right on that 1/2 right there. So that looks like that's good. This is what 3/4 would look like. Then you cut your halves in half. Kind of do it like this. That makes your fourths. Your 3/4 would be right here. So obviously, it's not going to be that 3/4. So it's going to be 3/6 and 1/2. Now, why? The two fractions are equal because they both divide the number line into two parts. Well, the 3/6 doesn't. The 3/6 actually divides it, into six equal parts and takes the third one. So it's not going to be that first part. Let's see. Are divided into six equal parts? No. See this first option here works for 1/2. The second one only works for 3/6. I need it for both because they both represent three equal parts. No, they don't. Are exactly halfway between 0 and 1. Yeah, see, that's the tricky part. Both 3/6 and 1/2 represent exactly halfway in between, right? Even if 3/6 cuts it into three equal parts and the 1/2 cuts it into two equal parts, they're both exactly halfway in between. So that is how we get our full credit. Let's see how we did across the state of Texas. So this one was tied for the fourth most difficult. You see, we barely got more than a quarter of our students getting full credit. That's our 2 points. They had to get all three correct in order to get that. Partial credit gets you 1 point. You had to get two out of the three correct. And then if you only got one out of three or 0 out of 3, you got 0 points. So this was difficult for many reasons. Number one, this is new item type, so we had the multiple select. As you saw, it was kind of difficult to navigate between the graph paper and then being able to access the actual drop downs. And so students might have not have known or just might have tired of kind of toggling back, so they just tried to eyeball it, and that's always a dangerous thing. This is only the second time that this TEKS has been tested ever on the STAAR test since 2016. So this might be a TEKS that is not necessarily taught as much because it doesn't have a rich testing history. And quite honestly, even if we could understand this 3/6 and 1/2, I think they really kind of threw us a bone here by cutting this into six. Would have been a lot harder if they had cut it just into half, and then they wanted us to see that 3/6 is equal to a half, but the visual represents the 1/2 instead. That would have been harder, so they gave it to us as 3/6. I think it was this one right here. This explanation is probably where students struggle because if anything, they're just to identify equivalent fractions on number lines, and then their only rationale is probably because they're in the same spot, and that's not the answer selection that they want them to choose here. So we need to provide students with different ways and opportunities to verbally and in writing explain why fractions are equal. First, find equivalent fractions, but then secondly, explain the rationale behind them because they are exactly halfway, because they are the same distance away from zero. If it is two fractions that are shaded rather than on a number line, right, you can say because they have the same amount shaded or the same amount represented, right? How do we verbally and in writing explain why fractions are equivalent rather than just finding equivalent fractions? For number 19, we are looking at real-world number pairs. This is TEKS 3.5e, a readiness standard in reporting category 2. And so this is a new item type called inline choice. And so we see here we need to either add, subtract, or multiply. And then we get 6, 15, 2, and 12. So let's take a look at what they're asking us to do here. We got a pet store, and we see this is a graph that kind of moves horizontally. And so we see this relationship between the number of aquariums and the number of fish. And since those are stacked on top of each other, we're going to be looking up and down like this. So to find the number of fish, okay, so equals number of fish. So that's what that says first, equals the number of fish. You blank the number of aquariums. Okay, so number of aquariums. So what do? We blank, we add, subtract, or multiply. Okay, so I'm just going to draw those three options. So add, let's see, we'll say, we'll do it vertically. Add, subtract, or multiply those by, what are my options? 6, 15, 2, and 12. By 6, 15, 2, or 12. And that gets us the number of fish. All right. So let's take a look at this. What can I do? If I get from 3 aquariums, I need to do something like that to get over to 18 fish. So 3 plus any of these numbers, 3 minus any of these numbers, or 3 times any of those numbers. Well, it's not going to be minus, right? I'm not going to subtract to get to a larger number, so we can get rid of that option. I could do 3 plus 15, or I could do 3 times 6, right? So that first one is typically always going to be uh, able to be answered multiple options. So let's check the second one here. 5 and 30. So 5, I'd said plus 15. 5 plus 15, that's only going to be 20. But 5 times 6, yeah, that gets me 30. Okay, so I like this times 6. Let's verify that the next ones work. I've got 9 gets me to 54. 9 times 6, yeah, that's a basic fact, gets me to 54. And then 12 times 6, does that get me to 72? If I don't have that fact memorized, I can multiply. That is going to be 72. All right, so it looks like we multiply the number of aquariums by 6. That's the answer. Let's see how we did across the state of Texas. So this was tied for the 15th most difficult, right in the middle of a 30-question test in regards to difficulty. Just a little bit less than half our students getting it for full credit. That means they both got both of those answers correct. Partial credit just got one. So you see, you put those together, you got 70%. That's not horrible. I really think that this is a pretty straightforward question, but it's just the inline choice that made it difficulty. And most of our students could sit here and probably do times 6, but having to write it in a complete sentence and explain it by words rather than simply by numbers and operations, I think adds a different layer of complexity. So when we are working with students on real world number pairs, 3.5e, after they find the rule, whether it's plus 15 times 6, whatever it is, have them write a complete sentence, including to find the number of fish, right? Have them write it like this. Have them write it in different ways. If you multiply the number of aquariums by 6, comma, you find the number of fish. Have them write two different ways to complete that sentence, because if they can't find it in a sentence, they're not going to be able to answer this question. For number 20, we are looking at place value relationships. This is TEKS 3.2b in reporting category 1. So what we have here is we've got three different numbers that are represented. We need to find which models represent the same number. So it's either going to be Anne and Karina, Karina and Zane, Anne and Zane, or none. So let's just take a look at what do we have here. I've got 100, that's 100 flat. I got a 10 rod. And then in regards to my ones here, I've got 4, 8. Interesting. Look, I've got an extra 10 right there. So if I wanted to add this up, right, I can just do 100 plus 10 plus 10. It's 120. Or I can just take these 10, right, and I could regroup them into an extra 10 rod, and that makes 20 right there. Okay, so this is 120. This is not 120. This is 100, and that's 2. So that's 102, right? Same digits, different order, big difference. Okay, so Zane is either going to have to be 120 or 102. And if you're thinking about it, it can't be Karina. It can't be 102 because all I have are 10s, right? So let's count the 10s. We've got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So if I did all of these right here, right, that's 100. And then I've got 110, 120. So there's my 120. So I have 100, and 20 because that's really just 12 tens. So if I were to draw that in my place value right, I'd have a 12 tens right there. Ends up being 120. So it's Anne and Zane. Answer here is C. Let's see how we did across the state of Texas. So this one landed a little bit on the easier side, the 11th easiest. We had a little bit more than half our students get it correct. But take a look at the distribution for the incorrect answers. Pretty even, which means 53% of these students knew how to do it, or most of them did. Maybe a few kids guessed it right. And then almost half really didn't know what to do. And so they just kind of guessed. And, you get an equal distribution typically when you randomly guess. So, what makes this challenging? Well, I think the one number that they could all get was this one right here. But what made and challenging? Well, this is an extra 10, right? So you have to include that in the tens right here. This right here was 100. So you ended up with 12 tens, and you had to be able to equate that with 120. That might not be something that they are familiar with. Same here. You've got, this 100 and this 10 and this 10 ones. So really, you've got to regroup this and make this, 100 and then two tens or 20. And so it's that regrouping that probably made this difficult. It was if they were all just like this, obviously there you would have two that would look exactly the same. So there's gonna have to be some regrouping. They just need practice to compose and decompose number in a variety of ways. And the more they get used to it, the more they'll be able to answer questions like this in the future. For number 21, we are looking at perimeter. This is TEKS 3.7b, a readiness standard in reporting category 3. So Vince is building a fence, and we know it is a rectangular garden. So the perimeter is 26. Okay, so we don't know anything quite yet, but they do give us this perimeter. So let's go ahead and label this as the perimeter. And what we need to know is that the perimeter is all the way around, right? It's the four sides. That's what the perimeter is measuring 26 feet. The length of the garden is 8 feet. All right, so let's just label this as 8 feet. Okay, so this is going to be my length. That's length. What's the width? All right, so a rectangle has length and width. Sometimes we call it base and height. Kind of depends. Right, so this length, so this right here is going to be my width. So that's what we're looking for. Width. So what do I know about this rectangle? Well, I know that it's got opposite parallel sides that are exact same length. So if the top is going to be 8 feet, you know what? I can say this also, the bottom here is also going to be 8 feet. So how much feet do I have so far? Well, I've got 8 and 8. That makes 16 feet. So there are 16 feet that I have so far. The whole thing is 26 feet. So how much does that leave me? It leaves me with 10 feet. But that 10 feet, take a look. I've got two different widths. I've got to split it in half, right? This whole thing needs to equal 10. So what we need to do is we need to cut it in half. And what's 10 cut in half? It's 5 feet. So if we make the width 5 feet, then that's going to work. And let's just double check. Let's make sure we got it right. We're going to add up all four sides. 8 plus 8 plus 5 plus 5, right? So it's 8, 16, 21, 26. So that double checks. Our answer here is 5. Let's see how we did across the state of Texas. So this was hard. The third most difficult problem, and you see that 27%, even though that's low, that wasn't even the most chosen answer. D got the most chosen answer. How did they get this 16? Well, if you take your rectangle here and you just say, well, length is 8, so the other side's got to be 8, and you add those together, and what do you get? You get 16. So we don't know whether there was a lot of guessing going on, because all of these do kind of get near 25%, which means we do have a lot of guessing, possibly. But more students chose this, and maybe they just remembered, oh, whatever's the one length, it's got to be the other length, right? You double the one of the sides. But obviously, that's an incomplete picture of perimeter because it doesn't even look at the other sides, right? What I would have understood would have been this 10, right? If they would have taken the 26, doubled the 8 to get the 16, subtracted that, and said, oh, there's 10 left over, right? That's almost all the way there. You see, they didn't choose that nearly as much as 5. So I'm thinking that students really just kind of misunderstood the whole point. There was no visual here. There's no picture. So the first thing I do is draw a picture. Have them draw a rectangle. Have them label. Do they even know what the perimeter is? Because if they don't know what the perimeter is on the rectangle, right, then they're just going to have to guess. For number 22, we are representing data. This is TEKS 3.8a, a readiness standard in reporting category 4. So we have a table here showing the number of reports, and they give it to us straight in numbers, not even tally marks. And we need to complete the bar graph here. And as you can see, all we got to do is click somewhere on the bar graph, and we can build it as high as we need to go. And so it's going to be pretty straightforward. So rocks is going to be 6. All right, we're going to hit rocks. We're going to move that up to 6. Animals is going to be 12. So we're going to put that up at 12. Now here's the tricky part is the oceans at 9. And so if we look, we're not going to see 9, so we probably need to label this, right? Let's find the intermediary numbers. 7, there's your 9 right there. Okay, so I need my oceans to go right there because that's between the 8 and the 10. So let's make sure I've got it. Check our work. That looks good. All right, that's it. That's all we have to do on this problem. Let's see how we did across the state of Texas. Well, we finally found the number one easiest problem on the entire test. Maybe they would have made it a little bit more difficult if they would have made us interpret tally marks, but they gave us the numbers, and all you had to do is click on the bar graphs to build your own bar graph. The challenge here, obviously, was this oceans, making sure that kind of gets between 8 and 9, because that number doesn't show up as a number on the vertical axis there. But you see, we had 79% of the students get it right. 13% get 1 point, right? Full credit is 2 points. And that means they got 2 out of the 3 correct. So you put those together, you're looking at 92%, right? And if there's any of the bars that probably messed up our kids, it was this oceans. But it looks like for the most part, kids got it. So good job, Texas. For number 23, we are comparing fractions. This is TEKS 3.3H, a readiness standard in reporting category 1. So Hector's got 4 circles. Thankfully, they gave us 4 different circles here that we can look at. And he divided and shaded the first circle to represent 4/6. Right, so we know that, remember, our numerator here, that's this top number, represents the number that is shaded, or the number selected. So I've got 1, 2, 3, 4 shaded. The bottom number, my denominator, is going to represent the total number of pieces. So 5, 6. That's why I've got 4 out of 6. So Hector will correctly divide and shade the other circles to represent fractions less than. Okay, less than. And then we need to find the one that is not the correct way. Okay, so let's do some drawing. He could divide a circle into 6 equal parts. All right, so let's try to do it 6 equal parts like this. And shade one of the parts. Well, is that going to be less than? Well, let's see. I've got 1/6, right? So that's what that's saying is 1/6 is less than 4/6. Yeah, as long as the denominators are the same, which they are, all you need to do is evaluate the numerators, and 1 is less than 4. So this one works, and remember, we're looking for the one that does not work. So not that one. He could divide a circle into 8 equal parts. All right, so let's try this. And shade 4 of them. Okay. 1, 2, 3, 4. You know, that looks less than, but let's see this. 4/8 is less than 4/6. Okay. Well, let me see. I've got equal numerators here, right? So since I have equal numerators, I can evaluate the denominators. And are 8s less than 6? Now, this is where it gets a little bit tricky. 8 is a bigger number, but you're breaking the same circle into 8 parts instead of 6 parts. The more parts you break them up into, the smaller each part has to be. Imagine breaking up a pizza into 2 equal parts and a pizza into 100 equal parts. Think about how thin those 100 equal parts would be. So the larger the denominator, the smaller the fraction. So 4/8 is going to be smaller than 4/6. So it doesn't work. Let's look at C. He could divide a circle into 4 equal parts and shade 4. Okay, so I just shaded in the whole thing. That definitely looks like it's going to be more. So 4/4, 4/6. So I've got equal numerators, right? So I can evaluate by my denominators. Are fourths smaller or less than 6? Now look at my fourths are larger than 6 because that number is less than 6, which means it's going to be greater pieces. Remember, I'm breaking up into less pieces. So that looks like the answer. Let's just double check. Let's see what we have here. 6 equal parts and shade 3 of them. So that's going to be 1, that's going to be 2, that's going to be 3. That's definitely less, but look, it's an easy one. I've got the same denominators, which means I'm just going to evaluate 3 is less than 4. Yeah. All right, so my answer here is D. See how we did across the state of Texas. So this one was on the harder side, the ninth most difficult. Take a look, 36% of our students got it right. And the incorrect answers were not exactly even, but they're kind of close enough to where I'm thinking there was quite a bit of guessing happening here. The one that they uh, didn't really get was this D. But what's interesting is that D and A are very similar, right? You at least have 6. You've got the 1/6 and you get the 3/6, and those are pretty easy to say are both less than your 4/6. The one that I could see is kind of challenging students, which were the two most chosen answers, were the B and the C. So how would I teach this for students? Well, you've got the visuals here. Some students might like this. You don't want to completely shy away from this, but for the most part, kids are not that great at coloring circles into equal parts, and you never want them to rely on that because there's no guarantee that they're going to have each part equal, right? Even when I drew the sixths, it wasn't great. So do you want them to at least have this as a visual reference? Sure. Teach them how to draw sixths and represent that. But really the key here is to write them in numbers. He could divide a circle into 8 equal parts and shade 4 of them. They need to know that's 4/8. So they need to represent it like that. And they need to know they're looking for something that's less than 4/6. If they could set it up like this, what they teach in third grade is that you can evaluate fractions with no pictures as long as you either have the same numerator or the same denominator. They don't really get into 4/8 is less than 9/12. They don't get into different denominators if the numerators are different. Not yet. That's more of a fourth grade thing. So the counterintuitive option for them to think about is, okay, if I've got the same numerator, what I'm looking for as a less than is the larger denominator. And this is where it doesn't make natural sense to a lot of students. They think, oh, bigger number equals bigger fraction, but bigger number equals more parts equals smaller for each part. So that's where the visual might help. They might need to see and have experience. Okay, how do I draw eighths into a circle? Because if they can't draw eighths into a circle, if they're only used to drawing eighths into a square rectangle, now you're hoping that they can make equal squares or equal rectangles. So it is good for them to practice drawing these pictures because they see that visual and they can easily see, all right, that is definitely going to be less. That's about a half, right? That's less than that 4/6. So lots of practice with drawing pictures of fractions, taking circles, taking squares, taking rectangles, breaking them up into fourths, sixths, eighths, but also showing them that the way to do it is probably the most efficient would be to just line up these two fractions next to each other, compare them with a greater than or less than, and then evaluate are they the same denominator, same numerator, and then go from there. For number 24, we are representing addition and subtraction problems. This is TEKS 3.5a, a readiness standard in reporting category 2. So we have two friends playing a game. First friend scored 339. The second friend scored 75 more than the first friend. Okay, which chip diagram could be used to find the total number of points both friends scored. All right, so we need a strip diagram here. And I'm looking for the total of both friends. All right, so both friends. All right, so let's represent our friends. Okay, we've got a boy and we've got a girl. What do we know about them? The first friend, okay, so he scored 339. The second friend scored 75 more than the first friend, okay? So 75 more than the first friend. So what I'm going to do is I'm going to take my 339. That's what the first friend scored. And I'm going to do 75 more than that. Okay, so let's see. I've got 14. That's 11. That's 400. Okay, so she scored 414. Now, I need to find a strip diagram that could be used to find the total number of points both friends scored. So I could do this, right? Let's just see what we have. What is the total here? 339. Okay, so 13, 5, 753 altogether. So I can say here's my total, right? And then I've got these two parts, right? I've got the 339 for the first friend and then 414 for the second friend. But I don't see that answer there, right? So take a look at what I actually added, right? So I added 339 and then I added that 414. That was a 339 and 75. So I'm going to keep that in mind. I know that my answer is 753. So let's just plug that into the question mark and see if that will help us. Well, that's not going to work because this is taking your 339 and subtracting 75. That's not even going to get you the score, the second one, let alone the total score, right? The total score means we're missing the total right here, the top part of the strip diagram, and 753 doesn't work there, so that's not going to work. Right now we take on B, the two 339s, and then you take away the 75, right? I'm not sure why you would do that. Remember, our total is 753, which means that's what we're looking for. That's going to be on the top. So this one is going to be probably chosen quite a bit because this 339 and 75, look, that's what this is right here. That's 414. That's what the second friend scored. I don't need to know what the second friend scored. I need to know what they scored together. So here it is, D. And so you see how I just combined my 339 and 75 into my 414 right here? They split it up. So this is your first friend, and then this is your second friend. Rather than putting it together, they just put the 339 and the 75, which is what I did right there. So that's our answer D. Let's see how we did across the state of Texas. Poorly. That's how we did on this. This is not only the hardest question on this test, this is the hardest question on any 2023 STAAR test. And I'm talking third grade all the way up through high school algebra 1. There is not a question that got a lower percent correct than a measly 8%. And I did not forget a digit. Only 8% of our students got this. Now look what the number one incorrect answer is. You probably glancing over this probably would have thought that as well, right? The first friend, 339. The second friend scored 75 more. Oh, they want me to represent how much that second friend chose. But that would completely eliminate this part of the problem right here. So this is just that this one friend in our representation, right? It was the second friend, the girl, that got the 75 more. So they completely missed the total number of both friends. They add, they added that word right there, both, and that's kind of the key word. Both friends, not just the second friend, both friends. Now, 36% chose A, right? So these students were probably looking at keywords. Okay, so I got 339 and more, and their teacher told them, oh, how many more, right? How many more always means you're comparing and subtract. Well, typically it does, but it doesn't say how many more. But they just looked in at that word more and probably said, oh, this looks like a subtraction, which it is. All right, you do your 339 minus 75, but that doesn't work. So this needs a lot of practice for students. Number one, I would suggest drawing a picture before you draw a strip diagram, right? So I drew my two little people and I try to figure out how they scored before I try to put it in a strip diagram. Put that step in there, picture before a strip diagram. Secondly, find the answer. What's the answer? Remember, I was able to put my 339 and my 339 and my 75 all together, remember? And that was my 753. So I was able to put in my 753 into each of these to help me evaluate, and that's the only one in which it made sense. So have them solve the problem, then find the answer of the best representation. Because you saw, remember, my original representation wasn't there. My original representation had the 753 and the 414, or the 339, excuse me, the 339 and the 414, and I didn't see it. So I had to go step by step. They might draw a representation on their own that they might not see, but that doesn't mean that it's incorrect. I was able to obviously see how they got the 414, and they just split it up into 339 and 75. So this is a multi-step problem. Students need practice with something like this and then reading all parts of the question, make sure they understand exactly what they're looking for. And if they say, oh, if I'm looking for the total and it's a strip diagram, I know then that my total is going to be that question mark at the top, whether you do it like that or sometimes you'll see it like this, and sometimes it's even at the bottom. But you're looking for something that goes across the entire strip diagram, right? Because if they did that, well, you can at least eliminate A and B. Now you're stuck between C and D. A lot of kids chose C, but that would at least eliminate two answers if they knew what the total was on the strip diagram. For number 25, we are comparing and ordering numbers. This is a readiness standard TEKS 3.2D in reporting category 1. So we've got a table here. We need to represent these states here on a list in order from least to greatest. All right, so let's take a look at these, and I'm just going to redraw them, but I'm going to put the place value here. So this is my thousands place, right? That's my hundreds place, tens place, and my ones place. So I've got Connecticut, and that's going to be 4,845. I got Vermont, 9,000. Oh, that's a lot bigger. 624. Hawaii, I've got 6,423. And then New Hampshire, 9,350. All right, so we're looking for least to greatest. So when we do that, we always look at the biggest place value first, right? So look at our biggest place value, and I'm looking at my 4, my 9, my 6, and my 9. And I can already tell you my first two answers. My least number there is 4, so Connecticut is going to be first. And look at my second is going to be Hawaii. So look, Connecticut, Hawaii, which means D's out and A is out automatically. Now, my Vermont and New Hampshire are both 9,000. Okay, so I've got to go to my next one. I'm looking for the least, right? And I'm looking at 3 and 6, and you see that 3 is smaller than 6, so New Hampshire, and then Vermont. So there we go. I've got it right there. Answer is B. Let's see how we did across the state of Texas. So this one was tied for the sixth easiest. Pretty good, 67%. And if you are a teacher reading this, you're probably, or listening to this, you're probably pulling your hair out because you know exactly what the kids did here. Vermont, Vermont, New Hampshire, New Hampshire, Hawaii, Hawaii, Connecticut, Connecticut. You had 20% of the students do all that work, and they did it backwards, greatest to least. So we had 1 out of every 5 students do the work. They just did it incorrectly, backwards. They didn't put it in least to greatest, they did greatest to least. So this is something we can continue to do for students, right? These are just guesses. So students really had no idea down here. But that could have been 87%. So we need to help our students once again clearly identify least to greatest and make sure that they relabel that, small to big if that helps them. Sometimes least to greatest, they might not even be 100% sure what those words mean, so we need to give them synonyms like smallest to biggest, um, and just make sure they're doing it in the right direction. For number 26, we are looking at multiplication as comparison. This is TEKS 3.5C in reporting category 2. Now we have a drag and drop here, and there are 4 blanks. So we've got this very simple statement here, 8 times 3. Now, Alex scored 8 points in a game, so this 8 belongs to Alex. And then the expression shows the number of points that Sarah scored. So if I were to draw Alex right here, he made 8 points. And then this 8 times 3 would show how much points Sarah. So Sarah is 8 times 3. So how do we put that all together? Well, if that's Alex, then what I'm going to do is I'm going to represent Sarah like this. Okay, so it took 3 Sarahs right there. Now, once we have our 3 Sarahs, that's going to represent the number of points that she scored, right? So there's 3 of them, right? And so 3 sets of 8. Okay, so that's what we got there. We've got 3 sets of 8. That's what the multiplication shows. Now, how do we complete this statement? Okay, well, we're going to notice that the words Sarah and Alex can only fit in these top or the bottom ones right there. Okay, and then 8 and 3 can only fit in this one right here. It can't fit in that last one. And then the more points than, and then 3 times as many points as, that goes in the last one. So it seems like a lot of options, but they don't all go in everyone. So who scored? And look at our options. More points than or times as many points than? Well, I'm going to use this times. So I'm going to use that first, right? More just means add. Times means multiply. Times as many points as. Okay, who scored times as many points? Well, this 8 times 3 is supposed to represent Sarah. So Sarah scored how many times? Remember, Alex scored 8 points and Sarah had 3 sets or 3 times as much as she did, right? So we're going to say 3 times as many points as Alex. That's one way that we can write a statement here to represent that Sarah scored 3 times as many points as Alex. So let's put that in there. Sarah scored 3 times as many points as Alex. That's how we get our full credit. Let's see how we did across the state of Texas. So this was the 11th most difficult, and we get 2 points here for our full credit, 39%, 1 point for the partial credit. Now to get full credit, you needed to get all 4 items correct. You actually got partial credit if you got 3 or 2 items correct, and then 0 points if you got 1 or 0 items correct. So how do we help our students solve this? Well, we typically will see this and we might see a little bit of a statement, but there's a big difference between matching a statement and writing a statement. And this drag and drop basically had our students writing the statement. So that's what we need to do when we're working on this particular standard, which is simply viewing multiplication as comparison, which is another way to view multiplication. Typically, we see multiplication as equal groups. So we need to have our students write a statement. If they could just write that from scratch, and trust me, it's harder than it seems, then they're easily able to do these drag and drops. For number 27, we are looking at the relationship between multiplication and division. This is TEKS 3.5C in reporting category 2. So we've got Miss Morales making 28 fluid ounces of sugar water to fill hummingbird feeders, right? And you see that looks like we've got our total right here. It says that's how much she made. So I'm thinking that might be my total. Let's keep reading. She put 7 fluid ounces into each feeder. Okay, so I've got equal groups. So I've got a total and I've got equal groups. When I see equal groups, I should think multiplication or division. So let's see if we can draw this right here. I've got 28 total. And then I've got equal groups of 7. I don't know how many groups there are. What are the total number of feeders? That's the total number of groups. So this is what the strip diagram would look like, right? You're going to think, how many 7s can I get out of 28, right? So we can use repeated subtraction if we want to, or we can just think of a basic fact. Most of us probably did that. How many 7s did I take away? 1, 2, 3, 4. Or you can think 28 divided by 7 equals 4. Now, I don't see that, but how do I find a related multiplication fact, right? And we're looking for this fact family here. We see it right here. 7 times 4 equals 28. Our answer here is B. Let's see how we did across the state of Texas. So this was right in the middle, tied for the 15th most difficult. A little bit less than 50% of our students getting this correct. And so obviously the only numbers we have here are the 28 and 7. And other than C, right? But the C at least included the 4, but that's kind of strange. But you got 28 and 7. We've got 28 and 7. We got 28 and 7. The question is, what do you do with those? So this is more about students being able to recognize the structure of the relationship in the problem, right? So you notice when I was reading this, this seemed like a total, because I know when I'm doing my strip diagrams, I normally put that on the top. And then 7 is equal groups. Now, this was the correct representation right here because you don't know how many groups there are. But, if a student wanted to even represent it like this, right? And they wanted to try to do, all right, 7 equal groups, that could have worked, right? Because then the question is what goes inside each of them. And once they see, all right, my missing number is 4 in that relationship, then they can easily solve this. But it all comes down to drawing representation and being able to pick out the total in equal groups if they exist in the problem. For number 28, we are composing and decomposing numbers. This is TEKS 3.2a, a readiness standard in reporting category 1. So which answer choice best describes? We got 9,140. All right, so let's make a little place value chart here. I'm just going to write 4 spots here, and I'll just put the place values. Ones place, tens place, hundreds place, and thousands place. Then I actually have my target number, right? 9,140. All right, so let's see if I can take these words here and build them underneath. So A, the sum of 9,000, so I'm going to put a 9 in the thousands place, and 14 ones. Okay, so I can't put 14, right, in the ones place. That's a, 2-digit number. What we do is we put the last digit in the place that's named. So that's what 14 ones is, right? A 14 ones is the same as a 110 and a 4 ones. So if I were to add those up, right, pretend like that we're doing expanded form here. Okay, you see that we're close, but the 1 and the 4 are in the wrong spots. But that's what we're doing here. So it's not A. Sum of 9,000s, okay, 100, and then I got 40 tens. Well, it's the same thing. 40 tens, I need to put that last digit in the place that's named 0. So then I end up putting a 4 right there. So 40 tens is the same as 400. So really, put that with my 100, ends up being 9,500. So I have to add the 100 they gave me and the 40 tens, which is really 400 together. So that's not going to work. The sum of 9,000s, 100, and 4 tens. Yeah, that looks pretty good. Look at that. That last one looks pretty good. Straight up. And then sum of 9,000s, 100, and then 4 ones. Okay, so put that right there. Yeah, that's not going to work. All right, my answer here is C. Let's see how we did across the state of Texas. So this was the 8th easiest problem. You see, we almost had 60%. And really, there's only one other answer choice that even got any notice, and this was B. And this is where it gets tricky, right? So this was the one where it was 9,100. But then you had the 40 tens, and so you had to stack those 40 tens right there. That turned that into a 500, right? That was the weird one. But look, 40, if you just look at the 40, that is 40, right? The problem is they're 40 tens. If this was 40 ones, well, now we're good. You turn that into 40 ones, and all of this shifts over 1, and it becomes perfect. So this is where we need to help our students just understand what happens when you have 40 tens. That still might be confusion for them. What happens when you have 14 ones, right? What happens when you have, 12 thousands? Well, most of us know that that's just 12,000. It's the same type idea, right? You take your second digit, you put that in the digit place that's named, and so you have to put the leftover to the left, right? 12 thousands is the same as 12,000. They need practice doing those overlap problems or descriptions here so they see what happens when you have 40 tens or 14 ones. For number 29, we are representing multiplication and division. This is TEKS 3.5b, a readiness standard in reporting category 2. So we have an artist painting skateboards, 4 flowers on each skateboard. So hopefully we see here that we've got each skateboard. That lets me know I've got equal groups of 4, so that means we are going to use multiplication or division most likely. And we need to find an equation that find the total. All right, so the total is missing. Okay, so what we're going to do here is we're going to draw a strip diagram, right? I'm missing the total 20 skateboards. So those are my 20 groups, right? So I can just draw a whole bunch of little lines here to represent each group, and I'm just going to do that and write 20. Let's just pretend there's 20 of them. How many flowers are on each? All right, well, there's 4 on each. So I could do repeated addition of 4 plus 4 plus 4 plus 4 20 times, or I could say, you know what, I've got 20 groups of 4, and that's going to be, well, 4 times 2 is 8, so 4 times 20 is going to be 80. So my answer here is going to be A. Let's see how we did across the state of Texas. So this was on the easier side a little bit, 10th easiest, 54%. We do notice that we've got the other one that's chosen the most is B, which makes sense because we're using 20 and 4, but instead we're dividing, which is another thing that we possibly do sometimes when we have equal groups. Now, the problem is the answer doesn't make any sense, right? 5 total flowers. It's not going to work if you have 20 skateboards and 4 flowers each, but they at least saw the 20 and the 4 and used division, which is something that sometimes you will do with equal groups. How we can help students here is to take our answer and see if that makes sense. Does it make sense that we have 5 total flowers painted on these skateboards? Even if you just wrote that there, 5, that wouldn't make sense if we painted 4 on each skateboard, right? That's where the 80 makes more sense. Okay, 4 on each skateboard, there's 20 skateboards. That's where a picture or a strip diagram really helps students instead of just trying to eyeball it, use the numbers, and put it in an equation. For number 30, we are representing equivalent fractions. This is TEKS 3.3f, a readiness standard in reporting category 1. So I've got 4 fraction models shown. I need to find 2 that are equivalent, right? So thankfully, these fractions actually have, they're aligned here, right? So we can actually just draw a straight line, and I'm going to actually change the grid size here, and I'm just going to draw a straight line. So watch what happens when I draw, let's try black. So look at this model W. I'm going to draw a straight line down. And we see it doesn't really match up with any of these other ones. So that fraction is 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 2 eighths. Doesn't really match up. So let's change colors. Let's do model X. And we see, yeah, you see how model X and model Z both come to that same distance, right? Because they are lined up here. So what do you know about model X and model Z? Well, model X is 2/4. This one also looks like it's eighths. It's 4/8. Yeah, see what they did here was they took each of these fourths and they cut them in half, and that equals the eighths, right? So you take a fourth, you cut it in half, you make an eighth. So those two are going to work. You see model Y, if we wanted just to finish this out, it doesn't connect with anything. So we've got model X and we've got model Z, right? That is going to be option B. Let's see how we did across the state of Texas. So this was tied for the 6th easiest, and really what made it not so challenging was the fact that we had all of these models lined up. If they're not lined up, that becomes a little bit trickier. We have to use other resources to try to do that. But you notice we had equivalent fractions here with different denominators and numerators. in Model X and Model Z, and they're not going to have you do that without a good visual representation until fourth grade. So we look at our incorrect answers, and they're split up pretty evenly. So, there's about 33% of the students that just really had no idea. They were just guessing. And honestly, maybe some of the students that got it right were just guessing. But for the most part, there wasn't any of these other choices that really stood out as extra. So we probably need to help students figure out, hey, if they've got it lined up like this, let's just draw lines and let's see which ones come to the same distance. Because if they are the same shape, right, equivalent fractions are going to take up the same amount of shaded area, even if the pieces are cut up into different sizes.